Hi everybody, it's great being here at Pyjamas speaking to you about software understandability. So my name is Liran Haimovitch and I'm the co-founder and CTO at Rookout, and I'm going to be speaking with you today about this new concept, software understandability, why it matters, why it's so important, and why should you care about it, especially if you're writing Python code for, web applications, batch processing, data processing, machine learning, and so on and so forth. So, to give you a bit of background, Liran Haimovitch, I'm the co-founder and CTO at Rookout. I'm an advocate of modern software methodologies, so I'm speaking in conferences and writing a lot about DevOps, Agile, Lean, Observability, Understandability, and also a very significant background in cybersecurity, but that's a topic for a different day. So, to give you some, I want to before we dive in, I want to go into what is Rookout and what makes me an expert on the topic. So, Rookout is a platform for live data collection and debugging. Using Rookout, software engineers, much like yourselves, can set non-breaking breakpoints and anywhere in their code and see stack traces, variable values, anything they want on the fly, and they can do that as the code is running remotely. So essentially, you pick a line in the code, you set a non-breaking breakpoint, and you see this line is being hit on that server. This is the server that's calling it. That's the stack trace, variable values, everything you would see in a traditional debugger. And the thing is, working with our customers, working with industry analysts, we've come to realize that debugging is not about going and fixing something that's called a bug in Jira. There is so much more to debugging and debuggers than just fixing bugs, whether it's those bugs that you find during development process, but even more so, it's about understanding your own code. It's about releasing a new feature and then uh, setting breakpoints to see what's going on, to see how the flow is executing, to see how the code is being hit, to to observe. It's about being able to take a look at a piece of code before you change it, so that you know what's going on and how to modify it. And this is all very critical and very basic to how we write code. And in a way, that's what understandability is about. Being able to understand our own code, being able to comprehend it. And so think of it like that. Uh, Let me give you a very simple, very straightforward example. I'm sure all of you know the JSON module within the Python standard library. And all of you had the experience of taking an input file, uh, parsing it using the JSON parser, and then verifying it meets a certain structure, or extracting a few attributes from it. Now, this is a task I'm sure you can get done in 10 minutes, maybe even less. If I were to tell you, take this file, extract those other attributes, and let me know if it meets a certain structure. But what if I were to take that same concept, that same file, and I were to ask you, go ahead and validate that input within a very complex system, within a very large system. All of the sudden, what you're thinking of is, how well do I know that system? Because if you don't know it well, then it's a nightmare. You have to go through all the code repository, maybe multiple repositories. You have to go through the components. You have to figure out where is that piece of data going through in the flow. Where can I make that change in the flow? What can I do about it? You have to think about stuff such as, how do I make that change? What are the performance implications? What are the stability implications? What's the best place for maintainability, for backwards compatibility, for forward compatibility, and so on and so forth. Now, if you understand the system very well, if you were there from day one, if you were the one to write it in the first place, then it's probably still not going to be a trivial task, but it's going to be much, much easier and much less intimidating if you understand what's going on. And that's what understandability is about. When we understand the application we are working on, then we can deliver high quality features very, very fast and avoid bugs, avoid pitfalls. While if we lack in understanding, everything is going to be messier. Now, obviously, if you've been there from day one, and if the system is reasonably small, then of course you can understand it. But understandability is about how hard or how easy it is to understand the system. It's not just about how easy it is for you to understand the system, but it's about how hard would it be to someone else from your team, or to a new recruit you have to onboard, or to someone else entirely. How hard would it be for him to comprehend the system and get things done? And that's going to make a huge impact on the team's productivity and on the value you deliver as a software development team. And I think being able to understand our system is so, so important, because in a way, software is like a Tower of Babel. There is no limit to how high we can build it, as long as we understand each other. And I really love this quote by George Bernard Shaw saying, "Imagination is the beginning of creation. You imagine what you desire, you will what you imagine. And at last, you create what you will." And honestly, in software, imagination is the key to everything we're doing. Anything can be achieved, anything can be done. We just have to imagine it and make it happen. And yet, too often with our customers, with industry analysts, we're hearing those kinds of things. 68% of organizations experience flying blind or flying slow, meaning we fail to live up to those expectations. We fail to live up to our imagination, because we can either fly blind, we can either not understand the system, which happens in many large organizations. We just don't understand it. This is a piece of Python code that was written, 15 years ago in Python 2.2. We ported it to Python 3. Nobody knows what's going on. It's using an archaic web library, and so on and so forth. And we just don't understand it. And so we make changes and we pray and we hope for the best, but everything is slow. We are going in the dark. We're blind people in the dark, so we're making very small changes. It's very risky, very high error rates, and so on. Or we can go slow. We can just add 5 log lines before every change. We can make 2 hotfixes. We can release 2 versions that are just to get more logs before and after we make a change, so that we make sure we don't break anything. We're going so super slow just to make sure we keep track of what's going on. Now, both of those options are very, very bad. And that's what happens when you don't have understandability. Now, if you were to have understandability, things would be so much better. And we've defined, with the help of industry analysts, the term of software understandability. We draw from the concept of financial understandability. If you're not familiar with it, I'm sure all of you have your finance providers, finance service providers, insurance funds, pension funds, insurance companies, and so on. In the past, those companies sent regular reports to their consumers, and those reports were unreadable. All bunch of numbers, everything is messed up, very hard to read. And so regulation came into play, requiring those financial service providers to provide the reports in a way their customers can comprehend them, so that they don't use obscurity as a tactic to rob their customers. And drawing upon that, we've defined software understandability. Understandability is the concept that the system should be presented so that an engineer can easily comprehend it. So, as I said earlier, understandability is about how can other software engineers comprehend whatever it is you're working with, how much failing to understand the system is blocking your path forward. And before we try and define understandability, we're going to do that in a second, describe the criteria for understandability. Let's take a step back and think about a software application. I mean, what is a software application comprised of? What is your Python application, whether it's a Django web server or a TensorFlow machine learning, whatever, comprised of? So first and foremost, I'm sure all of you are going to say source code. Because we are software engineers, our job is supposedly to write code. So it's all about the source code, right? Well, source code is definitely a very important, maybe the most important part of an application, but it's far from the only one. We also have the configuration and state of the system. Whether we are storing that state in memory, as variable values, dictionaries, whatever, or we are storing that state in a Redis database or a Postgres database, whether we are keeping we have configurations. That those can be environment variables, it can be stored in file or in memory or as feature flagging, but all of those elements have a huge impact on the functionality of the system, on the behavior of the system. Think how many bugs can be resolved by restarting a laptop or by clearing the browser cache. And that's so much is determined by configuration and state. And we have to understand that as well. Now, another element is the runtime environment. I mean, the same piece of source code might behave very differently if it's running in Python 2 or Python 3. It might behave very differently if you're using a different database with different locking primitives. Even more, the same piece of code might be very accurate, a great piece of code for a single-threaded application, but might work very badly if it's a multi-threaded application or if it's an active deployment and all sorts of things. And so we have to keep that into account as well. How is the code being deployed? How is it being run? And we have service dependencies, whether we're using third-party monitoring tools, third-party billing tools such as Stripe, or even first-party, other services within our company. All of those elements make up the application as a whole. It's not just about our small repo and what's inside of it. And last but not least, of course, the inputs and outputs of the system are critical. Critical. I mean, how are users using the system? How many users are using the system? Are they calling those endpoints with JSONs or XMLs? Are those endpoints being called once a second or 10,000 times a second? Are the buffers we are processing, or the files we are processing 100 bytes files, 10 megabyte files, 10 gigabyte files? Those are all going to make huge differences. And only by understanding all elements of the system, the source code, the configuration and state, the runtime environment, the service dependencies, and the inputs and outputs, only by getting all of that as a whole do we truly understand the application we're working on. Now, in order to understand the application we're working on, we have multiple criteria that the information that needs to be available for us. So first and foremost, we need information to be available, all the information. So if you're working with source code, we want access to all the source code. Now, I kid you not, I've met customers where source code access is regulated and not all the engineers have access to all the source code that's relevant to their day-to-day jobs. I mean, of course, they can do their jobs without getting access to the source code, but it's going to be harder. It's going to be harder to understand what's going on. And far more common, it can be very tricky to give engineers access to production databases, production configurations, because there you have security, privacy issues. And I'm not dismissing those issues. Those are real issues that have to be tackled. But if we don't provide our engineers, if we're not provided the information we need, then our jobs just gets harder. I mean, fixing a bug for a customer when you're blind, when you don't know their configuration and state, it's that much harder. Now, the second element you have to keep in mind is conciseness. So it's great to have access to 100 million lines of code in multiple Git repositories. It's awesome I have access to 100 billion database rows with all the information I might want, but I can't go over all of that all the time. I need some degree of conciseness. I need a couple of pages of introduction about the system. I need a summary about the database, about, for instance, the list of tables, the purpose of the table. We need to the information needs to be provided in a way that's easy to consume, that's easy to get started. Now, as we go ahead and shrink the data, we have to make sure we keep it clear. The information has to be clear, has to be provided in an easy to read manner. Some stuff is obvious, such as comment the code, keep it clean, but it's also about the documentation and everything else. So it has to be high quality. And last but not least, we need the information to be organized so that I can zoom in and zoom out. I can read the intro page and then I can move to the intro to this page for each component, and I can go into the API, like the IDE features, find all references, go to function, go to definition. Those are a great set of navigation features, but we want the same about how do I get from this, I have this code in front of me. How do I figure out what's its configuration in production? How do I figure out what are the inputs in production for this specific function? Those are great questions that we need to be able to answer. So how do we move between the various components of the system and the various dimensions of the system so that we can get a full picture of what's going on? Now, if we have all of that, if we have our information in a complete, concise, clear, and organized manner, then that's awesome. Then we know what's going on, then we understand it. But if we don't have all the information we need in that manner, everything becomes so much harder to understand. Now, as I'm working with many customers, many prospects, many in the industry, and first hearing about understandability, many folks think of different things that are closely related to understandability, but they are not the same. The first of those is complexity. Naturally, a complex system is harder to understand, but just because a system is complex doesn't mean it can't be understood. And just because a system is simple doesn't mean it's easy to understand. Let me give you a quick example. I'm going to provide you now with a Python script. Let's say 50 lines long. I'm going to tell you this Python script, its purpose is to read a file and provide an output. Now, on one side of the spectrum, I can provide you that script that has no documentation, no comments in the code, no input or output examples, and I'm just going to say, go and figure it out. That's going to be difficult because you're going to have to try to read through the code, synthesize inputs, and try to figure out what's going on. On the other side of the spectrum, I can provide you that same script with a document, let's say 2 pages, describing what's it doing, some comments in the code. I can provide you with some input examples showing what are the expected inputs of the system as well as their expected outputs. Now, all of a sudden, the task that I described that might have been a research, this task, figuring out what the script is doing, which is, could take a few hours, maybe more, maybe less, depending on complexity, becomes a task you can achieve in 10 minutes, 20 minutes. Just read the documentation, go through the code, run the script with a few examples, and see what's going on. So even though the system is just as complex, we didn't change complexity. I provided it with a set of tools, essentially more information to make the system more understandable. And that's critical. The second element, understandability, is not readability. Naturally, a piece of code might be very readable. It might be, maybe the code was written in very clean code, well documented, and the code is very readable. But maybe I'm not making that code available to all the engineers for security purposes. Or maybe the engineers have access to the code, but they don't have input examples. Or they don't have state examples. So just by a piece of code or a document being readable doesn't make the system as a whole understandable, but it definitely helps. And last but not least, observability. As I'm sure many of you are aware, observability has become much of a trend in DevOps and SREs. Observability is a term that is measuring, can I understand what's going on inside the system? Do I know the state of the system? By observing it from the outside. Now, observability generally measures very simple elements of the system, request rate, error rates, latencies, and so on. And observability is about letting site reliability engineers, or waking up in the middle of the night, know if the system is good or not, and if something is wrong, what is wrong about it. As I'm sure you understand by now, understandability goes much deeper. Understandability is about how the system is doing what it's supposed to be doing. What is the correct place to add this feature? Why is this bug showing up? And so on and so forth. So of course, observability data can help us with understanding the system. And of course, understanding the system can help us design better observability. The two are not the same. And so definitely complexity, readability, observability, those are all close neighbors, and we should seek to optimize them, and they all deserve their own respect, but understandability is quite different. So I'm hoping that by now you've got a sense of why understandability is important, why so many of the problems you faced in the past could have been resolved through better understandability, and why you should seek to optimize it. So let's see about how we can go about that. What can we do to improve understandability of new and existing systems? So first and foremost, we should minimize complexity. Now, there are many ways to minimize complexity. One would argue most software engineering is about minimizing complexity. So let's go through the obvious options. Cut back on requirements. Whether we are dealing with functional requirements, such as what the system can do, and non-functional requirements, how the system is doing it. Non-functional requirements are often trickier, but they include stuff such as performance, stability, availability, security, and so on. Each of those requirements make a system more complex, often exponentially more complex. The fewer requirements we have, the easier our target, and usually it's going to result in a simpler solution. Now, hire the best developers. Better developers are going to find simpler solutions to the same problems, which is going to result obviously in a system that's easier to understand. Utilize the highest level building blocks by using more advanced versions of Python, by using higher level web frameworks, by offloading database management to your cloud provider, and so on and so forth. You're essentially giving up some of the complexity of the system. You are handing off some of that responsibility to somebody else, to the interpreter, to the cloud provider, to whatever. And so your solution ends up being simpler. Apply software engineering principles, domain-driven design, clean code, dry, and so on and so forth. If you're going to write better software, if it's going to be simpler to understand, everybody wins. And last but not least, practice Agile and DevOps. By building your system step by step, you're probably going to end up with a simpler system with less over-engineering and more practical knowledge of what's going on. Now, I'm sure none of those 5 requirements are going to shock you. I'm sure everything mentioned here is pretty straightforward and you've had a chance to think through it. But before we dive in, I want to share another thought with you. So, everything I mentioned here, while maybe not trivial, it's definitely stuff you can and should do when you're building a new system. Unfortunately, when you're working on an existing system with an existing team, cutting back on the requirements that have been decided on 20 years ago, that's hard. And even if you do get to cut a few requirements out, you're not gonna re-engineer the system from scratch in a day. So all of those tools are great for creating a new system that's simpler. It's much harder to minimize the complexity, to remove the complexity from an existing system, and so we are better off with many of the other options I'm going to show you for dealing with complexity, to dealing with poor understandability in an existing system. And so that leads us to knowledge. The more we know about the system, the easier it is to understand it. Knowledge starts with learning. Go ahead and learn about the system as much as possible. Interview your colleagues. Grab a cup of coffee with previous colleagues who have left the company. Read the source code. Go through the databases. Sniff production traffic. Do whatever you need to get as much information as possible about what's going on. And write it down for yourself so that you remember it. I mean, the more you know about the system, the better it's gonna be, hands down. Once you've learned, document it. Write down what you've learned for your use and for other people's use. Build presentations, build a wiki page, whatever it takes. And then share that knowledge. Record sessions such as this. Have internal meetups, have team meetings. Share the knowledge you have, and encourage the team around you to find and fix any mistakes you might have made, to keep things updated as they change, and to collect knowledge as well and contribute it. And the more knowledge you have as a team, the easier it's going to be for you to handle the system, and the easier it's going to be for you to onboard new employees to that environment. The next item on our list is development environments. By building high quality development environments, we as software engineers have the pleasure of a playground. We can pick the application apart, we can put it back together, we can attach a debugger, we can see what's going on, we can experiment. And experimentation is a great way to learn. It's a great way to build and test new features, and so on and so forth. So what do we have to do? What do we have to do so that we can have high quality build environments to use? So first and foremost, we need to replicate the tech stack we're working with. So at least some of the development environments should be every development environment should be as close as possible to the production environments. And at least one of them should be very, very close as humanly possible. Starting with get the same operating system, get the same Python version, get the same dependencies version, which is obviously trickier. So think about using locking requirements to a file, building immutable container images that are easier to run in multiple environments, and so on and so forth. Use the same cloud resources. Just get your development environments in line with the production environments. The closer it is, the more you're going to be able to learn from it. Now, use high quality test data. Obviously, the best development environment in the world is going to do you no good if it's sitting idly by with nothing going on. You need high quality traffic going into that system, and whether you take that from production or you synthesize it or God knows what. It's difficult. It's non-trivial to get it right, but it's a challenge you have to take care of. Get high quality, replicate configuration from production to staging, replicate data in databases, replicate traffic, do whatever you need to do. And last but not least, keep in mind that you have to manage environments brief. As you add new services to the production environments, as you add new technologies, you need to add those to the development environments as well. As you add new APIs, you need to add the configuration states and inputs for them to the development environments as well. And even if you are not changing anything, maybe the business is going into new markets. Maybe your users are changing their behavior patterns. You have to keep track of that and make sure you have up-to-date, high-quality test data in development environments. Now, in the world today, the biggest challenge to development environments is the sensitivity of the data. For most of us, the data we are working with in production environments is sensitive data for security and privacy reasons. Most companies have limits on how data can be transferred from production to development purposes. And so it's a big challenge. How do we remove sensitive data from the core of the data without losing its value? Can we synthesize data? Can we buy data? Can we pay customers to work in non-production environments? It's a challenge, but one you have to face if you want to go down that route. And there are some benefits for getting it done. Then we have observability tools. As I mentioned, observability tools are all about seeing the innards of the system, but seeing the state of the system. Observability tools include stuff such as logging, tracing, metrics, and error tracking. Now, all of those can provide you with some insights into what's going on in the system. And so first and foremost, I recommend every company, every team that has those tools deployed, make sure each and every developer on the team has access to those tools. They're going to provide you with insights into what's going on. They're going to provide you with data points. Where is the code flowing? What is being called? How often? Where are the errors in the system? And so on and so forth. Unfortunately, the big downside of observability tools is that they only show you the outer sides of the system. They show you stuff. They show very well the external APIs of the system, and they have provide limited visibility into the business logic. You can add as many logs as you want to the business logic itself, but that's a tedious process. You add logs and then you find they're too noisy and you have to remove them. And every time you change the visibility, you have to release a new version. For some company, that's going to mean a few hours. For some company, that's going to mean a few weeks or a few months. But either way, it's a process. And so while observability tools provide you with great insight and great value into knowing what's going on in the system, they're also very cumbersome, fairly rigid and static, and you can't just tune them on the fly to answer the questions you might have. Now, last but not least, we have understandability tools. Understandability tools are just that. They are tools that are designed from the ground up to help us understand our code, to help us understand our applications, and to enable us to do our jobs. So, anybody has a guess of what's the first understandability tool? So, the first understandability tool is the traditional debugger, because that's what it's all about. I mean, think it. A debugger allows us to see our application running, even in slow motion. It allows us to stop at arbitrary points, see exceptions being thrown, and know every step of the system. How is the code flowing? Why is it flowing from A to B? What's the inputs over there? What's the state over there? We get full access, full visibility. We know everything. Unfortunately, debuggers can't be used in all environments. They can definitely be used on our laptops, as long as everything is working well. Once we start putting some other technologies, containers, Kubernetes, serverless, they might not be as easy to use. In certain development environments, traditional debuggers can be used, but in others they can't. So things become a bit messy, and they definitely can't be used in production-like environments, let alone production, because debuggers, by the nature, destabilize the system, slow it down, and are a bit of a hassle. And so this brings me to tools such as Rookout, next generation debuggers. debuggers that are production grade, that allow us to go into our code anywhere it's running, on our laptops, in the cloud, in containers, even in production. And using non-breaking breakpoints, we can answer any questions about the code. How often is this line being called? What inputs is it being called with? What state is being read from the database for this user? What's the configuration for that account? We can answer all of those questions arbitrarily by selecting the piece of code we want answers from, and just setting a non-breaking breakpoint, getting the data, and truly understanding our own code. Now, both traditional and next generation debuggers have their strengths and weaknesses, but I believe that over the next few years, we're going to be seeing more companies use a mixture of both to empower their engineers to better understand the software they are working with. So, I wanted to thank you for having me here today. I know the topic of understandability is very close to heart. We are finding this is making a huge impact on many organizations we are working with, and I'm hoping you have enjoyed learning a bit about it. I would be happy to continue the conversations on Twitter or on our website, so please reach out to me. I would love to hear from you. Thank you very much.